Good day once again. Welcome to today's class on calculation on acid-base titration. That is volumetric analysis. We want to see how to do the calculations on volumetric analysis. Before now, we have posted videos on how to do qualitative analysis of inorganic substances, that is salt analysis. We posted video on it and we stated a lot of points there that for WAEC base or for secondary school base, that the major reagents that is being used to check up which cation, which anions is sodium hydroxide and ammonia. That is, you are checking the cations, whether they are soluble in sodium hydroxide or in ammonia. That is one of the reactions or one of the analysis that occur in salt analysis via WAEC base or secondary school base. We also said in determining the anions present that sodium carbonate extract is always prepared. Sodium carbonate extract of that salt is always prepared. And we said the reason why we prepare it is so that it will remove or precipitate the heavy metals present in it. We said a lot of things in that video. Please do well to check the video Chidon's Daniel qualitative analysis of cations and anions. That is chemistry focus, chemistry practical focus, determination of cations or what anion, qualitative analysis of cations or anion. Perhaps go to my channel, you will see it. Okay, let's see how to do calculations on titration. Okay, remember another name for titration is volumetric analysis. We have calculation we can do there. Don't forget that when you talk about volumetric analysis, there is need for you to know what we call indicator. Indicator, they are weak organic substances which we use in running tests on volumetric analysis. When you have a strong acid and strong base, we use any indicator available to do the volumetric analysis. When you have weak acid against strong base, we use methyl orange to do that. Then when we have weak base and strong acid, we use phenolphthalein to do the volumetric analysis. Then when we also have weak acid and weak base, you can use any indicator to do that. That means we have many indicators in volumetric analysis: methyl orange, phenolphthalein, methyl red, bromothymol blue, and all have you. Please note this point. Then in volumetric analysis, it's also important to know what is the meaning of standard concentration. Standard concentration. I repeat, what does it mean? It means a solution whose concentration is known. A standard concentration is simply a standard concentration is simply a solution whose concentration is known. Okay, then we say you have to note that because it's very important. Okay, now we want to go into questions on acid base titration. That is what we want to consider for this video. For you to solve questions on acid base titration, there are many formulas that you can use in one point or at one point or the other. One of the formula is that molar conc of any substance is equals to mass conc over molar mass. Another formula is the formula that says C1 CAVA all over NA equal to CB all over NA. This formula was gotten from serial dilution formula. Serial dilution formula, because there is possibility that dilution will be done. Dilutions are often done in volumetric analysis, so we don't forget about this. Where Ca means concentration of the acid, volume of the acid, number of moles of the acid. From that equation, that is where we get Na from. Cb, concentration of the base, volume of the base, and number of moles of the base. Okay? Then this is a formula we can use to convert to molar conc, or to what? Mass conc, or to get the molar mass as well. Let's see the question now. 25 cm cube of a solution containing 2.0 gram of sodium hydroxide per 250 cm cube. They said the sodium hydroxide was given in what? 2 gram per what? 250 cm cube. The question is this the SI unit of what? Mass concentration? The SI unit is gram per what? Dm cube. Can we convert this to gram per dm cube? We say yes. 2 gram is in what? 250 cm cube according to the question. Then in 1000 cm cube, which is equivalent to 1 dm cube, what will it give you? 2 gram times 1000 all over 250. This here 4, that is 8 gram. That means that this is equivalent to 8 gram per what? Dm cube. This is what we call the mass concentration of sodium hydroxide. Mass concentration of sodium hydroxide, because mass is measured in gram. So since it is gram per dm cube, it means we are talking about mass concentration of sodium hydroxide. Then the question is, it requires 20.5 cm cube of a solution of tetraoxosulfuric acid for complete neutralization. Calculate the concentration of the acid. What do we call this? Volume of the acid, because they say of tetraoxosulfuric acid. So what do we call this? Volume of the base. The concentration of this is equivalent to per dm cube. This is mass conc. So what we now do is that we need to convert this mass conc to molar conc, so that we can apply it here and succeed in getting the concentration of acid in mole per dm cube. Okay, see how we do it. We now say to convert this to what? Mole per dm cube. Molar conc equal to mass conc over molar mass. So molar conc of the base, because sodium hydroxide is a base. Mass conc is what? 8. Molar mass. What is the molar mass of sodium hydroxide? Look at sodium hydroxide. Sodium was given to be 23. That is atomic mass of it. Plus oxygen 16 plus hydrogen 1. That is 3940. 40 gram per mole. And this is gram per dm cube. That will be given us, once we divide 8 divided by 40, that will be giving us 0.2 what? Mole per dm cube. Okay, then this is what we call our Cb, concentration of the base. This is our Vb. So we now say we have gotten our Cb, Vb, Mb. Wow, we have not gotten our Mb. We go to the equation. Okay, we are reacting sodium hydroxide with what? H2SO4 to give us what? Okay, this will go to this. Why this will go to this? That means sodium going with sulfate. Sodium is +1 and sulfate is what? -2. -2 will come down here. This will go down here. That will be giving you Na2SO4. So we have Na2SO4 plus this water will be giving you hydrogen with OH will be giving you water. Now, how many hydrogen do we have here? There are 3, but here is 2. It means it's not balanced. How many sodium is here? 1, here 2. We put 2 here. Sodium is now 2. Sodium is now 2. Oxygen is 2. Oxygen is 1 here. We put 2 here. Oxygen is now 2. Then hydrogen is 2, 4. Hydrogen is now 4. The equation is now balanced. It means that sodium hydroxide have ratio of 2:1 of H2SO4. So that means Nb will be equal to what? So Cb is what? 0.2 times Vb was given to be 25 all over Nb. Nb ratio of sodium equals to Ca. We are looking for you. Va 20.5 all over Na 1. That means that our Ca will be equal to 0.2 times 25 all over 20.5 times 2. So we say 0.2 times 25 divided by 20.5 times 2 in bracket. That will be giving us 0.122 approximately mole per dm cube. We have gotten our mole per dm cube, that is concentration of the acid. Can we get it in gram? Yes. To get it in gram, this is a mass conc. Mass conc, gram per dm cube means we are looking for this. Looking for this means molar conc times molar mass. So he said to gram per dm cube, we will be having, what is a molar conc? 0.122, that is approximated answer, times what is the molar mass? You write H2SO4. Hydrogen 1 times 2 plus sulfur 32 plus 16 times 4 64. This will be giving you 96, 98 times 98 gram per mole. So times 0.122 times 98, that will be giving us 11.956 gram per dm cube. So this is 11.956 gram per dm cube, and this is 0.122 mole per dm cube. Thank you for watching.